The figure shows a logo for an animal shelter. The curve ABC is a parabola with vertex at B. The curve DEF and GHF are identical portions of the same parabola with vertices at E and H respectively. So we're going to deal with the parabola part of the question first. So on my page, this center line running through the middle of the parabola, shown by the green line here. So in order to draw this parabola, I need to know the size of the rectangle that it's going to fit around the outside of it. So I can see here the dimension on my drawing for the height of the parabola, the rectangle to fit around the parabola, is 110 millimeters high, given by the dimension here, and the width is going to be from here to 1/2 of the parabola, which is going to be 58 plus 12, which is 70. So I'm going to draw a rectangle 110 high by 70 wide to fit around the outside of this parabola. 70 wide. Take a line vertically up using my set square, and 110 high. My parabola is going to fit, or half of my parabola is going to fit inside in this rectangle. So that rectangle would fit around the outside here like this. Okay, in order to construct my parabola, the procedure is I'm going to divide up the length of this side into an equal number of parts and take them vertically up or parallel to the axis running through the middle of my parabola. So from either side of the rectangle, it doesn't matter whether it's this side or this side, I'm going to take a line off at any angle. I'm going to choose to divide it up into 4 equal parts. So I'm going to set any distance on my compass and step off 4 equal distances along that line. From the last point on that line, I'm going to join it back to the other end of the line, and I'm going to take my lines parallel from that point through each of the divisions I marked with my compass. So that has given me 4 equal divisions, which I can mark here. 1, 2, 3, and 4. From the opposite side of my rectangle, I'm going to take a line off any angle. Okay, I'm going to divide this line into an equal number of parts also. So I'm going to take a line off at any angle, step 4 equal distances using my compass again. From the last point, I'm going to join to the opposite end of the line. And using my 2 set squares, I draw lines parallel to that line to hit the side. So I have 1, 2, 3, 4 equal divisions, and again I'm going to number them 1, 2, and 3. And the vertex on my drawing, I was told, was the point B here. That point B on my page is here. So I'm going to join each of those divisions back to my vertex B. I'm going to take each of these divisions on the horizontal line vertically up the page or parallel to this axis using my t-square. Set square on top of my t-square. I'm going to take those measurements vertically up the page. That has given me a series of points. So where the line 3 crosses the line 3 gives me a point. Where the line 2 crosses the line 2 gives me another point. and where the line 1 crosses line 1 gives me another point in my parabola. So each of these, bottom corner of the rectangle, point B, are all points on my parabola. I'm just going to join them up lightly for the meantime. So to join these points, I'm looking to go from the bottom corner here through this point here and on to the next point in a gradual curve. So it's going to do them roughly for the meantime in a green pen. It's a gradual curve between each point, getting into a position that is comfortable for you to draw it. So that gives me the left hand side of my parabola here. To get the right hand side of the parabola, this part along here, all I do is I can take each of the points, since the parabola is symmetrical, it's the same shape, okay, this part of my parabola is going through axial symmetry across this line, since it's symmetrical. What I can do is take each of the lines at 90 degrees to the axis of my parabola, take it 90 degrees across. Okay, I can pick any number of points I want and step the same distance on the opposite side of the point. So for this particular point here, I'm taking from the center line and marking the same distance across with my compass from the point 2 across using my compass, and from the bottom corner of my rectangle and over. So that has given me a series of points again. I forgot this point at the top. So taking this distance, my parabola will pass through each of those points, and again get into a position that's comfortable for you to join up those points in a gradual curve, and just lightly for the meantime, as we're only using a portion of the parabola. To locate the position of points E and H, I'm going to measure over a distance of 45 millimeters from the bottom corner of my rectangle and take a line vertically up the page, and that's going to be in line with the top of my initial rectangle. So on my drawing here, I'm going to measure over a distance of 45 millimeters from this corner, take a line vertically up the page, and it's in line with the top of my rectangle, which is also in line with point B. That gives me my point E on the drawing. And my point H is at 45 degrees to that line. So using my 45 degree set square, I'm going to draw a line off at 45 degrees from E. And looking back at my drawing, I can see that it's 10 millimeters over from the vertical line up through E. So if I measure 10 over from this line, take it vertically up the page, I will get the position of the point H on my drawing. So we're told that the curves DEF and GHF are identical to the initial curve here. So what I can do is, I can, for point C, I can take my points directly across the page and measure the same distance either side of my axis here to mark in the same points. I'm going to project over these points. I can take any points I want from the curve. So if I take this point all the way across, this point, okay, and I'm going to pick an extra point here somewhere, and taking the distance from the center of my axis to that point, since it's an identical curve, this point is going to be the same distance away. The distance from here to the parabola is going to be the same also, from the central axis. The distance from here to the edge of the parabola to point 2 will be the same again. And for my last point here, distance from here to the edge of the parabola will be the same again. So again, I'm going to join up each of these points lightly. Okay, getting into a comfortable position, continuous curve through each of these points. Give me the shape of that part of the parabola. The same on the opposite side. Let's get a third point to get an accurate curve. So that gives me the top section of this ellipse here. Next, I want to find an identical ellipse from point H. So each of these points are going to be the same distance away as the distance from E to H. So if I want to, what I can do is taking lines at 45 degrees to my curve, because this angle here is 45 degrees, and stepping this distance along the line. So I'm going to take a random series of points at 45 degrees. Might actually go from the points here. So lines down at 45 degrees from here. And since it's an identical curve, it's going to be the same distance away from each point. So set the distance from E to H, and swing from E to H here. Take a line at 45 degrees from this point, and from this point, from any random point on your curve, and set the same distance using your compass. So here, here, and here. And I can join these points up in the same order again, just slightly for the meantime. Through point H, and locate these points on the opposite side. I'm taking them directly across the point H. Point H will be joined through these lines here, giving me the point where they meet here, which is a little bit past point H on my drawing. So next, for the elliptical part of the question, we can see that the line that the minor axis on the ellipse is on is at an angle of 60 degrees to this line here, and it's over a distance of 70 minus, this here is radius 25, so the distance from here to here will be 25, so 70 minus 25 will give me 45. So if I measure a distance of 45 from the center line over, I'll locate this point to draw a line at 60 degrees, which my minor axis will be on. So measuring a distance of 45 over for this point, I'm going to use red pen this time for the elliptical part of the question. 45 millimeters over from my center line, and taking a line at 60 degrees, I know that my minor axis will lie somewhere along this line. I can see here this point M is the point at the bottom of my minor axis, which is a distance of 20 millimeters down from P, or down from the point B, sorry, along that 60 degree line. So if I measure down 20 from point B and take a horizontal line across, I will find my point M. 20 down from B, a horizontal line across, that locates point M here on my drawing. Now, my major axis is going to be at 90 degrees to this line here. Since this line is going at 60 degrees, a line at 90 degrees to 60 degrees will give me 30 degrees. So from the point M, I'm going to take a line at 30 degrees to give me a line that will be parallel to my major axis. Just going to extend that down the page. See in the question here, that will give me a line through point M, which will be at 30 degrees. I can see here the distance from the point M to my major axis will be 50. So I'm going to measure up a distance of 50 millimeters from that line. That will give me half the length of my minor axis, and again another 50 will give me the full length. So I'm going to take both of those lines off at 30 degrees. So that's giving me a line going through the point M, a line through my major axis and the top of my minor axis. So I know now the distance from my minor axis is the distance from here to here on my drawing, which on my page is the distance from here to here is my minor axis on the page. Now we were also told in the question that the focal points are at N and P on the drawing. So I'm going to mark those points N and P onto my major axis. I do not know the full length of my major axis yet. I'm going to use the focal points to find them though. So I can see that the point P is a distance of 22 plus 25 plus 15 away from my minor axis. So I have to measure that distance from the center line here up along to locate point P. So 22 was one marking. Sorry, it's 25 first. 25, 22, and 15. So 25, 22, and point here 15. This point here is a focal point on my drawing, that point. So in order to locate the size of my major axis, I know that if I take the distance from my minor axis to my focal point and swing it from the middle of the major axis, that's going to give me half of my major axis. Okay, I can use that principle in reverse. If I don't know where the focal points are, I take half of my major axis and swing it from my minor to get the focal points. I'm using it in reverse this time. So the distance from my minor axis to the focal point and swing it from the center of the major axis to give me the size of the rectangle that I need to draw to construct my ellipse. So taking a line at 60 degrees through the major axis, at 60 degrees the major axis this side, I'm going to use the rectangle method in order to draw my ellipse into this rectangle. I'm going to start with the top quadrant up here. So I might just put in the major and minor axis in a different color. My major axis is from here to here in blue, and my put in a thicker line. My minor axis is here in red. Let's make the line a bit thicker. So I have my major and minor axis, and I want to construct an ellipse given those two axes. So I'm going to draw a portion of the ellipse in this top segment up here. So what I'm going to do is I'm going to divide the distance from here to here into an equal number of parts. So I'm going to pick 4 equal parts for my question. So from one side of the line, I'm going to take a line off at any angle, step 4 equal distances off using my compass, And from the last point, I'm going to join it back to the side of the opposite side of the line. And take my lines parallel to that from each point. So from here, so each of those points, call it the points 1, 2, and 3. I'm going to join each of those points back to one side of my minor axis. Now this is my minor axis here, so I'm joining them to one side of my minor axis. So that's the top side of it, we'll call it. So from point 3 to the top of my minor axis, from point 2 to the top of my minor axis, and from point 1 to the top of my minor axis. For the second part, for constructing that ellipse, I'm going to divide this half of my minor axis into 4 equal parts also. So the distance from here to here into 4 equal parts. So I'm going to take a line off at any angle again. Step 4 equal distances along that line. Join the last point back and take my lines parallel to that from each point. So that has given me points 1, 2, and 3. So for the first part of the question, I joined the points to this part of the minor axis. For the second part now, I'm joining from the opposite side of my minor axis through these points. So from the opposite side of my minor axis through point 1, from the opposite side of my minor axis through point 2, and from the opposite side of my minor axis through point 3. And that is going to give me a series of points on the outside. So where the 2 trees meet, give me a point here. Where the two lines meet, give me a point here, and the 2 1s meet, give me a point here. So I can join up each of these points just lightly again for the meantime. To give me my elliptical shape. Getting into a position that's comfortable. Okay, and I know from my question, all of that part of the ellipse is going to be solid, so I'm going to put that in heavy, black marker. So we have a quarter of my ellipse drawn. So in order to draw the exact same ellipse over in this part, I'm going to take the lines across at 90 degrees to my minor axis. So that's just happens to be 30 degrees for this question. So I'm going to project using a purple pen point 1 across at 90 degrees across my minor axis, and I'm going to step the same distance on the opposite side of the line. Distance from here to here, because the shape of the ellipse is symmetrical. 30 degrees to the point 2. And step the same distance on the opposite side of the line. Give me these points here, and again I can join them up. Better off joining them up lightly first to get the curve. Going over heavy then once you're happy with the direction of the curve. That gives you the left side of the ellipse. To find the points in this quadrant here, we're taking the lines down at 60 degrees or at 90 degrees to the minor axis or the major axis. stepping the distance from my major axis to the point. I could also use the concentric circles method to draw this ellipse. I've chosen to use the rectangle method. Over that heavy, so I'm happy with how the curve is going. And for the final part of the ellipse, I can take these points straight down, or at 60 degrees, that is 90 degrees to my major axis. Take these points across at 30 degrees, or at 90 degrees to my minor axis. Again, giving me a series of points to join together that are on the ellipse. Drawing it lightly, my green pen. Once I'm happy with the curve, over it heavy. So the remaining lines on the question can be found by stepping over distances 60 degrees from this line and taking my lines up at 30 degrees from here. Whiskers can also be found by stepping a radius of 80 millimeters from this point here on the drawing and measuring off their angle with your protractor to find where these lines are.